Hello students, today we are going to start the chapter surface tension. Surface tension is a property of liquids due to which the surface of the liquid behaves like a stretched membrane. The surface of the liquid, the free surface of the liquid in contact with air behaves like a stretched membrane, as if a number of forces are acting on the surface which is trying to stretch the membrane and to decrease the area. So liquid has the tendency to to acquire the minimum surface area due to the property of surface tension. And this is the reason why falling liquids form in the shape of drops. This we will see in this chapter. Quantitatively, surface tension, this is the property. Now if we go to the definition, surface tension is defined as force per unit length. Total force acting on either side. Suppose we have taken a line AB. Okay. Now this line AB is on any imaginary surface. Now the total force acting on AB on either side per unit length, total force acting on this imaginary line per unit length is called surface tension. Hence surface tension is defined as the force per unit length in the plane of the liquid surface acting at right angles on either sides of the imaginary line drawn on that surface. Okay, this is the formula of so unit will be Newton per meter and dimension will be mt to the power minus 2. Okay, now let us see one example. There are many examples. For suppose you must have seen some insects crawling on the surface of water. They are not dipping inside water. Why? They can walk on the surface of water because the surface of the water is behaving like a membrane. You must have seen a needle whose density is much more than water. It floats on water surface. Why it is so? Because of the property that the surface is behaving like a stretched membrane. Okay. Now, example showing surface tension. See, let this is a wire gauge, okay, and this is a thread. This loop you can see is a thread. It is placed on a soap solution, on a soap bubble, okay, on a soap solution film, on a film of soap solution, and if we prick here inside the thread, you will see that this will acquire a shape, this way shape. This will acquire a completely circular shape, and this circular shape is because of the fact that liquid, due to surface tension, the minimum area it is acquiring, and this will get a complete circle. Why? Because the force are, you can see the arrow, the forces are acting in all direction in the outward, and this will make the loop a complete circle automatically. So this proves the existence of circle. There are many other examples you can see. Whenever liquid falls, it becomes spherical. Okay, forming of lead salts. The molten lead is poured in water, and automatically that converts into liquid. Okay, spraying of. So these are floating of needle. See, this is a needle floating on water, and okay, the weight is balanced by two direction surface tension. This surface tension forces acting tangentially. Okay, this surface tension forces acting tangentially from the surface of needle is balancing the weight of the needle. Otherwise, the weight of the density of needle is much more than water. Okay, so this is the reason, due to surface tension, this needle a denser quantity is not sinking in water. Okay, now, so what is the main reason for surface tension? That is the intermolecular forces. Now there are two types of intermolecular forces, cohesive force and adhesive force. Cohesive force means the force of attraction between the molecules of the same kind. Suppose water molecule, glass molecule, that is called force of cohesion. And the force of attraction between the molecules of different kind is called adhesive force. Okay, is called what? The adhesive force. So this is the difference between the cohesive force and the adhesive force. Okay, is that clear? Now, explanation of surface tension on the basis of intermolecular cohesive forces. Okay, now let us try to understand what is the reason for surface tension. Suppose a molecule is well inside the liquid, then the molecules nearby are pulling each other, and this is called the sphere of influence. Okay, and this sphere of influence, net force acting on the molecule is zero because it is balanced from all sides. This side force is balanced by this one, this side force is balanced by this one, this side force is balanced by this one. So net force acting on the molecule is zero. Okay, now what we do, we will take a molecule which is on the surface. Here also net, or here, let us consider this molecule which is on the surface. So when this molecule is on the surface, the net force are acting outward because there is no force molecule on the above this which can balance the downward force. So there is a net force acting downward. Here also some part of the molecules are not possible to be here, so net force is acting downward. And so similarly for every molecule on the surface there is a net downward force, and this net downward force is the reason for surface tension, and it is the reason for the shape of the meniscus and all things, along with the cohesive and adhesive forces. Now see, shape of meniscus. Okay, and we'll go to angle of contact now. The shape of meniscus, here, see, when you pour water in a glass, the shape becomes concave upward, and when you pour mercury, it becomes convex upward. Why this difference? It is because the force of cohesion between water and glass is the force of adhesion between water and glass is much more than the cohesive force of water. So this is the reason why it becomes a concave meniscus. But the force of adhesion between water and mercury and glass is almost nil. So this is the reason, and the force of cohesion between the mercury molecules is very much greater. So that is why the mercury does not stick to the glass. Okay, if you pour mercury in a glass, all the mercury molecules will come out. No one will cling in the glass, as we see in case of water. So what I mean to say is there will be no clinging of the molecules. Okay, so this is because of the less force of adhesion between mercury and glass. What is happening? We are getting this thing. Okay, so this is the main reason for cohesion and adhesion, the shape of the molecule. Now angle of contact. See, suppose this is any glass vessel and this is the surface. This is the shape of the liquid. So we have drawn a tangent to the shape, and this is the tangent on the surface. So as the surface is itself perpendicular, so no need of drawing the tangent. So this is the surface direction, and this is a tangent drawn on the surface of the liquid. So angle between the surface of the liquid and the surface of the solid is called the angle of contact inside the liquid. This angle should be inside the liquid. So what is the definition? The angle inside the liquid between the tangent to the solid surface, this one, tangent to the solid surface, and the tangent to the liquid surface, and this is the tangent to the liquid surface. So this is the tangent to the solid surface, this is the tangent to the liquid surface. The angle between these two is called angle of contact. Okay, so due to the same thing, more cohesion, less adhesion, the angle of contact between water and glass is very less, about 7 degree, 8 degree. Okay, in pure water glass it can be 0 also. But in case of mercury, the angle of cohesion is a obtuse angle, more than 90 degree. Why? Because of the convex meniscus. Okay students, study up to here, and in the next class we will continue.